everyone. The paper we will discuss today is the IFMIF-DONES project Preliminary Engineering Design. 1. Design Description 1.2 Plant Configuration. The DONES plant is defined to provide an accelerator-based deuterium neutron source to produce high-energy neutrons at sufficient intensity and radiation volume to simulate as closely as possible the first-world neutron flux and spectrum of future nuclear fusion reactors. The plant will produce a 125 mA neutron beam, accelerated up to 40 MeV and shaped to have a nominal cross-section in the range from 100 mm times 50 mm to 200 mm times 50 mm, impinging on a liquid lithium target 25 mm thick and 260 mm wide, cross-flowing at about 15 ml per second in front of it. The stripping reactions generate a large number of neutrons that interact with the material samples located immediately behind the lithium target in the test modules. The main features of the IFMIF-DONES plant and the modifications with respect to the IFMIF design configuration are as follows. Only one accelerator is considered by the angular configurations is maintained in such a way that a large upgrade to a two-accelerator layout could be feasible. The radio frequency system is based on the solid-state amplifiers operating at 175 MHz in order to assure high reliability operation. The liquid target of lithium will flow at a speed of 15 ml per second, nominal. As in IFMIF, the first approach is that the lithium target will have the same physical dimensions as that of IFMIF. The test cell TC will house the lithium target and the test module as well as the lithium quench tank QT, which will be larger than the IFMIF one. It should be able to manage the full IFMIF power. IFMIF-DONES will be designed preferable, aiming to provide high flux irradiations of structural materials. Therefore, the current approach is the HFTM will be the only irradiation module present in the TC with an enlarged thickness as compared to the IFMIF IIEDR configuration to gain additional irradiation volume. In addition, the HFTM could be backed by a neutron reactor to improve its nuclear performance and reduce the radiation to the TC wall. Other irradiation modules or experiment could be included as well as the result of additional needs identified in the future. Unlike the IFMIF plant, where one beam footprint of 20 times 5 cm² was foreseen, IFMIF-DONES systems HEVT lithium target HFTM etc. should be able to handle different footprints. The objective is to cover a range from 10 times 5 to 20 times 5 cm². Figure 1 depicts a schematic view of the current configuration of the IFMIF-DONES plant. The IFMIF-DONES product breakdown structure (PBS) identifies 5 major groups of systems. PBS Level 1. 1. The site building and plant system. 2. The test systems. 3. The lithium systems. 4. The accelerator systems. And 5. The central instrumentation and control system. 5. The central instrumentation and control systems. The PBS is used as the reference structure of all engineering design documents of IFMIF-DONES plants. Thanks for listening to the end of today's show.